Hola a todos. Hi, Lauren, Leo. Thanks for being here. I will switch to Spanish to introduce you to the audience. Buenas tardes a todos nuevamente. Espero que hayan disfrutado la charla de Sebastián, que fue excelente. Ahora empezamos nuestra segunda charla del día de hoy, donde tenemos el placer de poder escuchar a Lauren Hill, a Leon Kuperman, Chief Product Officer and Chief Technology Officer de Cast AI, quienes nos contarán cómo vivir una aventura de implementar aplicaciones en un entorno multicloud usando Kubernetes. Pueden compartir sus consultas o comentarios en el chat de la derecha o en el canal de Discord Containers and Kubernetes. Leon, Lauren, it's a pleasure. Would you like to start?
Thanks, Santiago.
Yes, please. Yeah, thank you, Santiago, and buenos tardes. Oh God, I hope I say it right. Good afternoon, guys. It's a pleasure to be with you. So my name is Laurent, one of the founder of Cast, and Leon Kuperman is my dear friend and co-founder in Cast.ai. We want to show you a little bit of an adventure and how you can deploy and use Kubernetes in a multi-cloud scenario. We're going to show you a little bit of the reason why we're so excited with multi-cloud, with some of the data that we gathered, especially in terms of disaster recovery options. And you may have seen AWS was done yesterday for most of the day in US East. We also will show you some pricing efficiency. So there's a lot of reasons to go into a multi-cloud scenario. It could be for optimization of cost, it could be for resiliency to outage, and many other benefits. Leon will show that to you in real life. So let me start by sharing my screen. Here, let me do that now. I think you guys can see my screen?
Yeah, go into full screen mode.
Cool, thank you. So an adventure in multi-cloud with Kubernetes, let's go. This is who we are. I will start by a bit of history, then it's a demo or it does not exist, and then the developer journey. So we hope we will not do yet another boring presentation. This is not about slides. This is about telling you a story and showing to you how that happened. First, when we speak about Kubernetes, I'm sure you see some of this quite often. I need to know why moving our app to the cloud didn't automatically solve all our problems. You wouldn't let me re-architect the app to be cloud native. Well, just put it in containers. You can't solve a problem just by saying techie things and then the person say Kubernetes. And we see this a lot. These big words are used left and right, sometimes rightly and sometimes not as accurate. So we want to fix some of this. So a bit of history of why Kubernetes, why container. Early 2000, people started to meet, especially large enterprises in the Americas and in Europe, and say, look, we're having all these machines in one place. Why don't we move them in a co-location where we can at least share electricity, air conditioning, and physical security? That's the birth of the co-hosting or co-location data center. Early 2000, then Amazon came in and says, well, you know what? These machines, these bare metal machines are great, but they're not used very well. So let's virtualize them. Let's densify a little bit more these machines. So now the bare metal machine is using more than one VM. So you kind of try to reuse the same compute a few more times with VMs. However, one of the issue we had here, and I'm sure you guys have seen some of this, is, well, with VMs, you actually spend a lot of things you replicate a lot of things that are not very useful, in particular the operating system. And sometimes that can become heavy. And then suddenly you have the same problem as before. You have a lot of VMs that are not very well used just because you can't put too many of them inside the same bare metal. That was the birth of the container. And this is why we're so excited. The idea here is just a very lighter version of VM, you can say it this way, where you can densify a lot more compute resources inside the same physical machine. That was the idea of container, and this is why we are so excited. I mentioned this because Kubernetes made multi-cloud possible, and this is why we are focusing on the use case of Kubernetes. And the last point is there is no much debate anymore. It's Kubernetes. Our friends at Google did a good job there. Kubernetes has won the race. Let's embrace it. Let's not think of other options anymore and go full speed with this. what is multi-cloud and why we're talking of multi-cloud, and then why this is an adventure. The first one is, this is how we see the cloud right now. So you are here, and you have these huge boxes with big walls between them. This is Google, and then you have AWS, of course, and you have Azure, and a few others would be gravitating around it. This is how we see multi-cloud. Multi-cloud is a place where you should not have any walls between your application. And in fact, as a developer, you should even feel that an application should move freely. Why would be constrained physically by having an app running only on machine that happen to be owned by AWS? And why is this? Why this happening to us? Where if you want to use Google machine learning engine with maybe a database that live inside AWS, well, that should be possible. There should be no reason why we can't do this, especially as we use Kubernetes and containers, which are supposed to be portable. So there should be no real reason why we have this evil vendor lock-in of AWS versus Google or versus Azure. This is how we see multi-cloud. It's a place where you should be able to deploy, as a developer, an application on an infrastructure that may happen to be shared across several providers, just because you want it, or because there are a lot of benefits linked to this. And I'll show you some of the benefits. So, and this is why that's part of the adventure. One of the benefits is this one. So you may have seen yesterday AWS was down in US East. This is actually an image that was tweeted many, many times with people complaining about AWS being down. This is actually a screenshot of a friend of mine who suddenly could not turn on his electricity because Lutron is using the cloud and they are using AWS only. It happens to be US East, and dude, you can't turn on your light now, or you can turn them off unless you use the button because AWS is down. This is how terrible an outage can be. This is the big outage. Many times we see micro failures or micro outages where just one service is down. Here, AWS did a good job there to shut down everything they had almost in US East. And so when AWS sync, why should we sync with it? So why are we constrained to not moving an application outside of AWS if we need to? Just because if AWS goes down, I want to make sure that I'm not impacted too much by it. This is one of the benefits of multi-cloud. The second one is the vendor lock-in, and we call it evil. I know that's a phrase that Google love to use, but they apply that a little bit to them as well. Vendor lock-in is evil. I'm going to show you an example of this. When we started the company, we looked at 84 different regions all over the world, and we look at whether these machines offered by cloud providers are similar from one to the other. So we benchmark them. We benchmark almost 500 machines over the entire world with this cloud provider. I'm going to show you a quick demo difference of this. So here I want to compare Amazon with cloud, Google, with Azure, and with Oracle. Just a moment. Here. I'll take US East, and I'm going to show 4-core machines. So the typical VM 4-core machine of all these cloud providers in US East, and this is the result. So now what I'm doing is I'm comparing how much compute buys you $1, and I compare this with a benchmark over different cloud providers. So here's the result, and you see how staggering this is. So the best price is actually Google Cloud. It's a 4-core machine. This is the name. You may be familiar with this. It's a 4-core machine with 4 gig of memory. It costs you $72 per month. This is the list price. And for that amount, you're buying something that is effectively about 40% of compute. 100% of compute would be the highest of the 4-core machine. 40% means compared to the highest, most performing machine within this class of 4-core in US East, you buy about 40% of this. The endurance is quite good, meaning these 4-core machines are always available to you at any time, all the time. So it's very stable. But look at the first one. The first one is Oracle Cloud. It's also a 4-core machine. This is the name of the machine. Look at this. For about 12% more, you're actually getting more than twice the amount of compute. And this was staggering for us. This was eye-opening. This means, well, if you remember this place where you had the walls, if you break the walls between cloud providers and you're able to move your whatever you need a 4-core machine or all the containers and the workloads of that 4-core machine to Oracle, you just save 40% of your bill just by doing this. And if you compare Google with, Oracle Cloud with AWS, the difference is 56%. If you compare Google and AWS, the difference is 15%. So you see, this is why we say cloud providers are evil, or vendor lock-in, is evil, because it should not be like this. Price are very different, but they should not lock you in so you cannot benefit from this price difference between cloud providers. And guys, we did the same in Brazil, we did the same in India, the same in Japan. The same type of difference is everywhere in the world. Even though US East is maybe the biggest location, you can go to EU Central, you can go to Asia, you can go to South America and Brazil, you'll find the same price difference between cloud providers. The second thing that would make this possible is what we call the Goldilocks zone. The fact that all these cloud providers are in many ways 5 milliseconds from each other. I'll show you very quick one more study we did. This is a little bit more of a data science study. I'm going to show you the latency that we calculated between cloud providers here. I'm making this bigger. Between cloud providers, and we wanted to verify, are these cloud providers really located in the same place? So here, if I compare, let's say, I wanted to compare, here. If I compare Brazil East, São Paulo, this is Oracle. So Oracle is 1.5 milliseconds away from AWS in Brazil. It's 3.4 milliseconds away from Google Cloud, and it's 4.7 milliseconds away from Azure. This means that if you think of this as, well, I want to deploy an app in São Paulo for Latin America, let's say, or Miami would be also another option. I want to deploy an app in São Paulo. I effectively could use machines in all these 4 cloud providers because they are so close to each other. Then if they live in the same network, effectively there should be 0 performance issue by using these 4 cloud providers in São Paulo. The same is true for US East. The same is true for all the locations they have, because these cloud providers are the same as human. They look at the best place to be, and the best place are the same for everybody. So this is the reason why the adventure is possible. The fact that, yes, you have a lot of places that are nearby so much so that if you could federate this machine to the same network, you can effectively use them as a giant blurb of VMs, all connected through a same secure network. The second thing is, it's great because there are so many cost optimization options if you are able to move stuff between these cloud providers, because they don't price the same way, and they are very good at not telling you this. And the third one is, one of the strong benefits, especially since yesterday, is this idea that if one cloud goes down, and your application happen to live across many more locations or many more clouds, then it should not impact your location. I stop here. I'd love to have Leon show this to you. So Leon, it's all yours. Let's show how we do this deployment. Back to you, Leon.
Thanks, Laurent. I'm just going to share my screen here. We just got a couple more slides before we go into the actual demo. So guys, imagine you get this company-wide memo from your management team. Dear employee, excellent news. Our company is going multi-cloud. Make it happen. Of course, managers love to say, make it happen. And so you go through the development journey, lots of denial going through the journey. So first is confusion. What are you talking about? Like, how are we going to do multi-cloud? And then you go into the denial mode. There's no such thing as multi-cloud. Finally, you get angry. Who decided this? And then you start asking or bargaining. Well, maybe we're multi-cloud already. Hey, we use Gmail, we use Dropbox. Maybe, no, those PaaS services don't count. And so finally, you get to the point where you say, okay, we got to do something. How are we going to get it done? So what we're going to walk through today is we're going to build a multi-cloud Kubernetes cluster. But before we do that, I just want to walk you through some architectural options, because there's a lot of ways that you could potentially do this. So at the beginning, you really need to pick a technology. And so containers are given, but you don't want to limit yourself to cloud native technologies. Functions, serverless is a up and coming technology set. You want to be able to use Lambdas or functions or Knative So you don't want to limit yourself to only containers. And we do believe that Kubernetes is a standard. So that's what we've chosen for this particular demo in terms of orchestrating a multi-cloud application. So once you get there, you kind of have a couple of choices. And the first choice is, do I do multi-regional, like do I deploy technology in multiple places in the world, or do I pick a single region and create a multi-cloud environment in that single region? Multi-region is a harder problem because you have long lag data problems. So you have to deal with eventual consistency. You have to deal with your application is going to have to know that it's sharded, that it is a multi-region application. Single region is what we're going to talk about today. And we think that's a good choice to get started. And once you work in a single region, there's really a couple of different approaches to a single region technology set. The first one is independent clusters. So this is kind of what Google Anthos does, is you create a lot of different clusters, and each one of them is synchronized with one another through a set of config pushes. So you're pushing policy and configuration to those clusters. And then they behave in a similar way, but then again, they are not really one logical entity. They're really a set of logical entities that kind of have to work together. Again, your application has to kind of know where the barriers are. The second choice is cluster federation. We think this is a hard problem because you have to use underlying technologies. So there are a lot of service meshes that will kind of help you mesh technologies together. You're going to need custom resource definitions. You're also going to have to code your application in such a way that it understands kind of the boundaries between clouds. So we call that cluster federation, and there are a lot of federation projects that exist. The approach that we're taking is a very unique approach to the industry, and it's what we call a stretched cluster. So a stretched cluster is one logical unit. You operate it as one Kubernetes cluster. You take traffic in as one logical unit, but you do not think about but you don't have to use resources from a single cloud. So I could use compute from all three clouds. I could use storage and network and load balancers, and these resources are mix and match. And that's what we're going to build today as part of our demo. So for a stretch cluster, it's really important to have that Goldilocks zone that Laurent was talking about. 5 milliseconds is kind of the borderline that we thought about as a reasonable way for Kubernetes to work together across multiple virtual networks in such a way that etcd doesn't have problems, which is the underlying database, and can replicate very well. You can also use the best of cloud native services. As Laurent mentioned, if you want to use RDS for your database, but you might want to use a machine learning toolkit from Google, you might want to use Azure Active Directory for identity. There's no reason why you can't use those resources together in a logical application, but you do so over private IPs, over a private network, without ever having to kind of go over public links to get to various services. Out of capacity is a huge issue. Back when COVID started, we had entire companies, no matter how big their budgets were in the cloud, where AWS would say, sorry, Mr. Customer, you cannot have any machine. We don't care if they're spot instances or on-demand instances, we don't have them. So if you're stuck in a very specific part of AWS, for example, you're kind of hosed. If you can extend your application to burst to other clouds that are within a few milliseconds away, you have lots of extra capacity, and you can actually work the market as an open market. And the same is true for spot instances. If there are no spot instances available in a specific region in AWS, you can certainly get preemptible instances in a region in the Google, same region as in Google. So just to go over the vocabulary, a master is a Kubernetes master node. A node is the thing where all of your pods are placed, and pods are like your container deployments that get placed on individual nodes. So the first thing we need to do is we need to pick a location. So for the purpose of this demo, we picked Sao Paulo. We're about 1,675 kilometers away from Argentina, 28 milliseconds latency. That's pretty good. We think that that's a pretty good trade-off to get 3 clouds in a very specific area. So that's the location that we've chosen. And you need to go create accounts in all. So if you were going to do this on your own, you would need to go get accounts in AWS, Azure, and GCP. All of them have good free tier and sign-up programs where you get a lot of bang for your buck. Once you've gotten your cloud accounts, the next thing you have to do is you have to make sure that you have virtual machine to virtual machine communication. So that could be over VPN. which is the way we've set it up for this demo. It can be over a direct connect, which is a layer 2 connection, tying data centers together. But you also have Kilo, which is an interesting project for Kubernetes that uses WireGuard, which is a VPN tunneling protocol built into the Linux kernel that allows you to do VM communication without relying on cloud provider VPN services, which can get somewhat expensive. Once you get to VM communication, the next really important thing is, can your pods talk to one another? And if you want, and that is really, you want your pod to be able to use core DNS just to look up a service name, like give me my shopping cart service, and you don't care where it is. And that pod-to-pod communication is really critical. Calico is interesting, but it has challenges, especially with Azure, because Azure tends to drop packets when it doesn't realize what the source, when it doesn't understand the source IP. So we've chosen a layer 2 CNI, which is called Cilium. Really great performance so far. And what's great about Cilium is it doesn't use a layer 7 proxy like Istio. So you're not incurring the extra latency of layer 7 proxying all of your pod-to-pod communication. So we've got our pods, we've got our VM set up, we've got network communication. You need some block storage provisioning. So I'm not going to go into the details. The basic point here is that when your pod lands on a particular node in a cloud and you want to provision some block storage, you need to have a driver that understands the cloud that you're on, and also doesn't care that it's on a different cloud, maybe from one deployment to another. So the good news is we have a CSI driver that we're going to be open sourcing soon. That's the one that we're using for this demo. But essentially, when a pod lands on a node, you're good to go. The CSI driver, without being in the data path, will automatically provision block storage for you. It can expand that block storage volume live. So it's a do snapshots and backups. Pretty cool technique. You also want data portability, and so the key thing here is that you want to have data residency where your workloads are, and so there's a lot of different middleware that will handle that application level replication. The couple that we've been playing with, Yugabyte DB, is a great distributed SQL database that allows for multiple copies of your data so that you have really fast reads everywhere and synchronized writes using ACID compliant database. But Elasticsearch will give you eventual consistency. Kafka will obviously be a good message queue for you. So there's a lot of really nice technologies available for block storage portability, all the way down to OpenEBS. Not one that we'd recommend because of the performance hit. You're sitting in the data plane and you're getting a 10x performance hit as a result of using something like OpenEBS. So you also have to worry about compute provisioning, and you have to worry about things like shapes that Laurent talked about. You have to worry about node auto-scaling. Now, if you're just on an individual cloud like AWS, no problem. Node auto-scaling works great. But if you're working across multiple clouds, there's no open source project that we know of that kind of gives you that multi-cloud node auto-scaler. And that's one of the challenges we're trying to solve. There's also challenges of horizontal pod auto-scaling. So Sebastian showed a great one with Knative. We're using one called Kada, Kubernetes Event-Driven Autoscaler, under the covers. That's not necessarily a multi-cloud problem, but it is something you're going to have to worry about if you want to scale your applications, and that includes vertical pod sizing and auto-scaling as well. And then the last piece is, once you've got all of your computers set up, your network set up, you need to way to ingest data, ingest traffic. So to ingest traffic, you need something like a DNS global load balancer. That's what we're going to demo today. And that's going to route traffic between your public cloud, public endpoints. So in this particular diagram, we have traffic. First DNS resolution occurs. It either lands on AWS and Google. It goes all the way to your workers. And then your ingress controllers actually terminate TLS, and you end up at your target service. But really, if a cloud goes down, you want to have some way of removing it from the traffic flow. So a global load balancer is a great way to do that. And finally, let's get to the demo. So we're going to, so we've got these demos, demo YAML. And
Leon, you have 10 minutes.
I got you. We're gonna deploy one of the demos that's under Cast AI/examples. So we got 10 minutes. So let's get to it. We've created a cluster here in Sao Paulo. It's running on 3 different clouds: AWS, Azure, and Google. And we've already pre-provisioned everything, so we don't have to get through. So you'll see on the right side of my screen all of the things that have to happen from security groups and networks and VMs to make this all happen. The demo app we're going to deploy is the Google demo app. I'm going to show you the YAML file, and there's really two things that I want to focus on. This is a normal Kubernetes deployment YAML, very vanilla, except there's a couple of interesting points. The first one is, how do we make sure that we have pods that are evenly distributed in certain clouds if we care? So for this particular service, and there are 12 total services that we're going to deploy, the front-end service really needs to be deployed on one of AWS, Google, and Azure. And so we're using node affinity to do that. And we have a special label on the nodes called a topology label. And this particular part of the template makes sure that those pods are, this particular front-end pod gets deployed in AWS, Google, and Azure. And the last thing I want to show you is kind of the ingress piece. So what we've done is we've created a domain name called ARQCONF.privatesales.com, which is a demo domain that we have. And we are using it for two purposes. One, to serve traffic, but also we're going to provision a real-time Let's Encrypt certificate as the TLS certificate manager of choice. So all of that is kind of built into the CAS cluster, and that's what we're going to use to deploy. If I go back to my UI, if you download your kubeconfig file from here, you're going to be able to access this multi-cloud cluster. And I've got this cluster configured with Lens. So let's do this. Let's go over, let's go to our default namespace, and you'll see that we don't have anything deployed right now. And let's take that YAML file that we just looked at, and I'm doing this in real time as opposed to pre-deploying this. So kind of daring the demo gods, but let's go ahead and deploy the boutique app that we just took a look at on the YAML file. So, oops, I am in the wrong terminal window. Okay, let's do this. Give me 1 second. Okay, cool. So we're going to go ahead and deploy these 12 services. It's going to take about 60 seconds to deploy, maybe a little bit longer. So as we're waiting for these deployments to turn up and our 14 pods to run, I'm just going to show you a little bit about the network. So remember, we talked about a set of nodes that are in different clouds. So you can see here, I'm getting all of the pods kind of in a wide deployment. And you'll see that I've got some of my nodes that are in AWS, some of my nodes in Azure, and some of my nodes that are in Google. And so these are all connected through that virtual multi-cloud network that I talked about. And you can be saying, well, Leon, how is that performance of that network? So remember, we have Cilium installed as the network interface here. So what I'm going to do is I'm going to actually look at the Cilium health status, and that'll give us the ping times between all of the nodes. So you can see here, I've got a little bit slower. So I've got 5 millisecond ping time, 4 millisecond HTTP agent response time, 6 and 4. So it's in and around the 5 milliseconds that we talked about at the beginning of the presentation. So kind of this is the moment of truth. I've got my pods deployed. And one of the things that I didn't show you at the beginning was this was the result. Like, so this ARQCONF.pri, and this domain, you guys can, maybe Laurent can throw it into chat, was giving a 404 Nginx error before because obviously we had absolutely nothing deployed. Let's go ahead and refresh this and see if the demo gods are with us. So you'll see that my boutique app was deployed. This particular page is actually, I'll make it a little bit larger so you guys can see, is actually being served from Google. But if we refresh the page, you'll see that our global load balancer that we've provisioned is actually rotating the traffic through our 3 different ingress points, Azure, Google, and AWS. And also you'll notice that this is HTTPS traffic. So we didn't just deploy some dummy endpoint over HTTP that's unsecure. This certificate was provided in real time by Let's Encrypt as we deployed that particular YAML file. And the way we did that was in our console, in our CAS console, you'll notice there's something called the GSLB DNS domain name. All we did was we plugged that into our DNS provider for that host name, and that's what provided the multi-cloud global load balancing that we got out of this demo. The last thing I just want to show you on the Boutique app is it's the persistence across clouds. So if I add this particular item to my shopping cart in Google and I refresh the page, you'll see, one, it's lightning fast, but two, and I'm going all the way to Sao Paulo from Toronto to fetch this page, but two, that shopping cart is consistent across clouds, including the persistence layer in the application. So the last piece that I wanted to show you on the demo is one of the things that's really important, obviously, for a multi-cloud cluster like this is observability. One of the things you'll notice is that we have Grafana metrics that are built into our cluster. So you'll see our Grafana dashboard that has a full set of pre-built Prometheus metrics ready to go for day 1 and day 2 operations. That's the demo. I want to just finish off by just talking a little bit about infrastructure as code. So for this type of project, it's really important to deploy. You're going to want to codify everything that you're doing. So invest time in infrastructure as code. CloudFormation, not a great choice for this type of project because it's too vendor specific, but Terraform has providers for all of the clouds, and it's a good choice for codifying. In fact, Cast has a Terraform provider. If you want to try out cluster creation on Cast, it's free to use right now. Go ahead and grab your early bird account. And that's it. That's the demo, guys.
Thank you very much, Leon. Santiago, do we have any question?
Thank you so much for the presentation. Let me see if there is any question. No, we don't have any. But I really appreciate your time. The presentations were really awesome. Let me see the great demo. No, we don't have any questions.
And guys, one thing for all the developers online, if you guys are interested, yeah, you can either go to the booth or you can apply directly. Go to console. I'm typing it on the chat. But cast.ai, go there. We know you guys are coming from the conference, so you'll never be charged for it. You have free, unlimited access. You'll be able to create your cluster. It's all Kubernetes open source, so it's all the same. As you know, I think it's 1.18. And for now, you can deploy in US East, US West, EU Central, and Sao Paulo on your own cloud accounts. We will add 9 or 10 regions in the next few days. And by the way, I forgot to say, we actually launched this yesterday. So Santiago, thank you so much for this opportunity. If you guys go to TechCrunch, you'll see an article about us. Yeah, this is really brand new, and it's the first time we show it in the public. So thank you, guys.
That seems very interesting.
Thank you.
Thank you, Lauren. I appreciate the time.
Thank you, Santiago. Thank you, guys.
I'm looking forward to continuing the contact in the booth or Discord. Thank you.
Thank you.
Bye. Bueno, ahora en unos minutos preparamos la siguiente charla y volvemos. Como dijimos un rato, quienes quieran conocer más sobre Cast pueden ir al booth y ahí le dan acceso gratis a la plataforma para que puedan jugar y probar con ellos. Nos vemos en unos minutos.